In this video, we're going to talk about centralized DHCP. If you want to use centralized DHCP, meaning one DHCP server for multiple networks, you will need to do something for the clients that are not on the same network as the DHCP server. Because remember, the clients use broadcasts and routers don't pass broadcast traffic. So there are two options, a DHCP relay agent or an RFC 1542 compliant router. So let's take a look at this scenario. I have one DHCP server on the left, which is on one network. And then on the right, I have a client that's on a different network. To enable this client to receive an address via DHCP, I need a DHCP relay agent. What happens with the relay agent is that the client sends out the broadcast. Help, is there a DHCP server in the house? The relay agent listens for DHCP broadcasts and then relays them directly to the DHCP server. When the DHCP server replies, the DHCP relay agent broadcasts the reply on the network so the client can get it. With an RFC 1542 compliant router, and usually that would be a physical router, then it's the same thing, but effectively what's happening is that the router is configured to pass the DHCP broadcast to a specific DHCP server on another NIC on the router. And so RFC 1542, it's just a standard for routers. So if it meets that standard, you can program it to do this. So here it would be a physical router. The client sends out the broadcast. The router relays that to the DHCP server. When the DHCP server replies, the router is going to put that out as a broadcast on the network for the client to get. So we're actually going to check this out in the software. But before we do, let me show you what the environment looks like. So right now, I have a router. It's actually made with a Microsoft server. So it's not an RFC 1542 compliant router. We're going to be turning it into a DHCP relay agent. So kind of combining the two. That router is attached to 3 switches. One switch on LAN 1 has a DHCP server connected to the switch. Second switch, LAN 2, has a client 1 connected to the switch. And then the third switch is connected to the internet. Let's go take a look at our DHCP server. So we're here on the DHCP server. LAN 1 is this 192.168.1.0 network, and that's actually the network that this particular server is on. You can see its name is DHCP1, and there's its IP address 192.168.1.110. LAN 2 is 192.168.2.0 network, and the client is actually attached to that. And right now, let's go in and look at the statistics. So far, it's seen 1 discover, it's made an offer, a couple of requests and acknowledgments. Let's go over to the client and see what happens over there. So I'm here, my client. It currently has a static IP address for the 192.168.2.0 network, and it's using 192.168.2.1 as the gateway, and it has internet access, no problem. So everything is working great. Let's change this over to DHCP. I'm going to go into my network card and say, no, you don't need a static IP address. Let's do DHCP instead. And you can see it hasn't picked up an IP address. At some point, it's going to fail over to a APIPA. There's the APIPA address. And the problem is, of course, the client is sending out that broadcast, but the router is not passing that broadcast over to the DHCP server. And let's just pop over to our DHCP server and confirm that. So back on our DHCP server, I'm just going to refresh my statistics. And you can see DHCP discovers is still 1. The client never got that broadcast. So what we need is a DHCP relay agent. So we're going to go over to our router and configure a DHCP relay agent. So I'm here on my router, which I have creatively named router. You can see it's got 2 IP addresses, 192.168.1.1, 192.168.2.1. And in a Microsoft server, the software that allows it to be a router is routing and remote access. Right now it's running NAT and it's doing general routing. We're going to add in a DHCP relay agent. I'm going to do a new routing protocol. There's my DHCP relay agent. And it's just that easy. Now, 2 things we have to tell the relay agent. The first thing is, what network card should it listen for broadcasts on? So I'm going to go ahead and add a new interface and say you should listen on LAN 2. That's the LAN that doesn't have a DHCP server. And yes, you should relay DHCP packets from LAN 2. Second thing my DHCP relay agent is going to need to know is, where do you send those packets? That needs the IP address of the DHCP server. So we would go to properties and say, well, you can send it to 192.168.1.110. And now my relay agent knows everything it needs to relay those packets. So let's go back to the client and tell it to try again. So back on our client, let's try an ipconfig renew. It can take a little bit more because it's going through the relay agent to the DHCP server and then back through the relay agent. But there's our address, 192.168.2.70. Looks great. And just to confirm it, we'll take one last look at the DHCP server. So let's go ahead and open our statistics. And you can see that the discovers used to be 1, now it's 2. So it did, in fact, get that discover via the DHCP relay agent. So that's it for centralized DHCP. We took a look at the issue with centralized DHCP, which is that we have to have some way to get the broadcasts from the network that the clients are on to the network with the DHCP server. And there's 2 ways we can do that. One is with a DHCP relay agent, which is a server that's configured to relay the packets. And the other would be with an RFC 1542 compliant router.